Welcome to This Week in Environmental Health. Hello students, today we're going to talk about... So radon gas is a health risk. It actually causes lung cancer, and only smoking causes more lung cancer deaths than radon gas. But if you look at the risk of radon gas, if you look at this particular chart here, you can see that deaths from radon actually causes more deaths per year than drunk driving. And the interesting thing is about radon gas is very few people actually know anything about it or even realize that there's a risk. And there's actually a pretty big risk in... So I encourage you to go to the PowerPoint and watch this video. This is Mike Holmes. He talks about radon gas and shows you some of the mitigation methods that are used in homes. We'll talk about that too. But check out the video. It's pretty short and pretty informative, so it's worth a watch. So what is radon gas? Radon gas is, radon is an element, and it's produced as a byproduct of radioactive decay. So if you take a look at this, we have uranium here, and uranium, of course, has a half-life, and it degrades. It turns on to radium, and that also has a half-life, and then we got radon, and radon is a gas, and it has a pretty short half-life, which is actually what makes it quite dangerous. When you have things that degrade quickly, it means they degrade in your lungs if you inhale it, and of course they're going to cause damage to your DNA, and damage to your DNA leads to cancer. So where does radon gas come from? Well, it's found in the soils. Found in other places as well, but kind of primarily in the soils, and then of course from the soil the uranium degrades, eventually turns into radon gas, and then ends up in some of these other sources. You can see well water, outside air, building materials, and things like that. But mostly in the soils, and considering we have all our homes on top of soils, this is where the risk is. If you take a look at this, this is saying how does it enter a house. You can see it's in the soil, and as the radon gas is produced, it creeps up and gets released into the atmosphere. If you have a house, it can get through cracks in the house or through all sorts of sources, end up in the water and those kind of things, and ends up being inside your home. So this is just a slide talking about the health risks. I'm just going to skip over it here in a moment, but you can see that Health Canada here actually has a recommendation, and they are talking about a certain limit. So 200 becquerels of radon gas. That's a measure of radioactivity. There's a bunch of different types of ways to measure radioactivity in different units. You can see above we have 10 picocuries per liter as well as listed. And there's conversions between the different types of measurements. So here is another infographic looking at what's acceptable and what's not acceptable. This is in picocuries, and you can see I've converted this to the becquerels. I believe this is the American recommendation, saying that 4 picocuries or 148 becquerels per meter cubed are safe. So you can see the green is 1, the yellow 2.6, and so on. This is the recommendation from Health Canada. You can see they're using a different scale and different units. They're saying 200 is okay. I don't know why Canada has a higher recommended level. Sometimes that may have to do with the fact that we just have more natural ambient radiation in Canada than these other countries, but I'm not entirely sure. So take a look at this here. This is the yearly exposure to this level is equivalent to 30 medical chest x-rays. That's huge. That's a lot of x-rays. So getting up to this level, this 200 level, is actually pretty high. And so if your home is in kind of within that range, you can see they're recommending action soon. The recommended is that you do something within 2 years if you're at that 200 level. You can see the average level outdoor is 10, and the average indoor in Canada is 45. Okay, so let's take a look at this. So where are we in Canada? Well, we're in the boreal forest, so Fort McMurray has got to be, I don't know, somewhere around here. And so that is the high zone. So that means we have a good potential in your home that you may actually be exposed to radon gas. You can see most of Canada is actually in the same category here, except for pretty much the Canadian Shield. So the Canadian Shield is kind of, right here. most of the Canadian Shield. Actually, the Canadian Shield does go into Northwest Territories. I think it actually maybe goes more like this. You guys probably know the geography a lot better than I, since you've talked about it in Neil's classes, and I haven't done any actual geography since about grade 9. But point is, Fort McMurray is in a high zone. It doesn't mean that every home is at risk. In fact, here's the thing. Your home could be high risk and your neighbors could be low, or the other way around. You don't know unless you actually test your home. There's many variables. It kind of depends on what's in the soils beneath your exact house, the construction material, are there any cracks in the basement, all those kind of things. So what do we do if we have radon gas? There's mitigation that you can do. There's lots of companies that you can Google it. I found a company that said Fort McMurray radon mitigation. Basically what they're trying to do is vent it. There are different ways to do it. You can see this one here has a little fan that's put in under the basement into the soils, and it basically sucks the gases, including radon, in there and then vents it out the rooftop. You can see there's some photos on the right where this one's going out through the attic, going through the wall, and looks like that. Here's another picture, somebody who's having it vented, and the vent actually goes outside of the house. So that's kind of the main thing that they do, is they try to find a way to vent it. Usually they're looking at venting underneath the basement, is what they're looking at. This is a chart here talking about different radon mitigations, so you can see some of the other things that are done. For example, sealing major gaps, improving indoor ventilation, so some houses are just designed a lot better to improve the ventilation. You can see these other things about underfloor ventilation with a fan-assisted pump. So usually it's looking at trying to improving ventilation and getting the toxic gas out. So I wanted to finish off this topic and show you this here. When I started learning about radon gas a few years ago, I kept thinking to myself, I should get my house tested. I have an older home. So I did that. I found a test kit that I could order online. I think it cost about 30 bucks. Some of them were a lot more expensive. I basically went for the cheapest one that I could find. What you end up is you get this little device. It looks like a miniature, kind of like a hockey puck. You take it out of the package, you remove a seal, and then you find it a place to set it for, I think it was 80 days or something like that, or more. I put it in my basement. It's not supposed to be on the floor. It's supposed to be 4 feet or a meter like that from the ground. So I found a shelf, left it there for the 80 days or more, and then I mailed it in. And they end up giving you this report. So here's the good news. I'm under 100, so no recommended action. My house is in good shape, and cost me 30 bucks, and now I have a little bit of peace of mind over this whole thing. So if this is something you're concerned about your house, they do recommend most people get their houses done, particularly older homes. But newer homes are not necessarily immune, particularly in Fort McMurray, where some of these houses were put up pretty quickly, and different degrees of quality construction. And of course, with houses heaving over the winter, sometimes that causes cracks that we're not even aware of. So that ends this topic, and I think we have one more to discuss, really, which wraps up the semester other than the term projects. Hope you're all doing well. Have a great day.